All right, so we are back. Small coffee break. I hope you enjoyed the commercials. Now are going to talk about Mark 59, the JMeter Selenium CI open source performance validation solution. We've been connected since this morning. Stephen Towson has already makes a small reference about Philip's Webb talk. So you will see it's quite interesting. So if you're they build a DSL driving Selenium, so you can basically script and build your performance test there, combining JMeter and Selenium. So I'm pretty interested, especially for those who's been utilizing Selenium for pure load testing. Sometimes it could be quite heavy in a sense. One important, the open source website. So just sharing at the moment as we speak the GitHub page for the open source project. So it's GitHub IAGCL Mark 59. You can find everything. Everything is documented. You can see the Maven dependencies and so on. But once we have more details from Philip, for sure it's going to be much more easier for you to utilize it. I would recommend to start using it. I guess once you start using it, you will have probably a lot of questions, and Philip would be more than happy to answer them. So just if you don't if you have not heard about Philip, Philip is based in New Zealand. Has more than 30 years experience in the industry. He's been an expert in mainframe, working with IBM mainframes. He has got a developer background and also a Java developer background as well. And now it's been working for IAG since more than 10 years. And since the last 5 years now, he's a performance and volume test analyst. So I think has a lot of things to share. And I think having him as a new pack member, it's quite excited, especially because he has this fresh new open source. And I think it makes sense that Philip talked about it. So Philip, I give you the ball, so you can continue giving more details about this awesome framework.
Okay, thanks a lot there. Okay, I'll just see if I can start my slide pack. Okay. Okay. Okay, so yeah. Have you got that?
Screen yet. I don't see a screen yet.
Let's have a look. There, 5. Share screen. Sharing.
All right, and now I can see your screen. Perfect.
Ah, cool. Okay, cool. Yeah, so I should say I don't do a lot of presentations, so there might be a few hiccups going through. Anyway, I'd like to thank Neotys for inviting me along today. Stephen Townsend for the recommendation to speak, and thanks Henrik for helping out the preparation work too. Oh, by the way, I'm actually talking from Australia, so it's the other side of sort of the Tasman Sea there. I just wanted to start with a quick outline of the background in which we developed the open source framework, the Mark 59 framework we're going to talk about. Just the fact that it was developed just in a small working performance and volume team, like we're not a software team or anything specialist like that. We're a pretty self-contained and self-managed team, so we were relatively free to really think about how we could improve the way we do things, over time. 2 or 3 of us have been in the team for, probably the 4 or more years that these ideas I'm talking about today were developed. But over that time, we've had lots of people go through the team, lots of skilled P&V people, and they've come up with many of the ideas that we've actually included in the software. And we've had lots of ideas from other testers here in the office and Java development team as well, actually. I'm going to break the talk up into two main bits. The first bit is kind of the timeline, how we actually progress the software, how we actually progress from being what I would call a very traditional sort of performance and volume team, working with TSRs, test summary reports, test plans, that sort of thing, then how we moved into continuous integration and how the Mark 5.9 software came about. And depending on how I time things, which I'm not sure how that's going to go, I'll try to get to a little bit of an overview of how we actually perform the Selenium scripting, and maybe a little bit of detail about how our continuous integration actually hangs together. Now let's see. Henrik's already sort of talked about my background. Probably the only thing I'd add is those early Java projects I worked on, they were agile projects. They were ThoughtWorks driven, right back in the early days actually. And I think those early projects have always sort of been sort of a drive for me into process improvement. Maybe how things can be, or maybe even should be improved in IT. Our day-to-day working environment, I would call a pretty typical IT environment. It's basically a multiplicity of projects. We have poles of different languages and a mixture of in-house and packaged solutions. Mainframe and Java applications do currently dominate, but there's lots of other stuff too. We have automation testers assigned to projects, updating and running automation regression suites, currently in a variety of languages, although again, Java is actually where they're heading. The IT infrastructure here is VMs running as servers and so on at a data center, like most places, and of course the Z-series mainframe. Again, like a lot of corporations, we're heading towards cloud systems. In fact, really, I can't see how anything but cloud is anything but inevitable these days. And to me, I get the feeling that means we're also possibly heading towards a period of change in performance and volume testing. Things do change quickly. I can think of back in those mainframe days, mainframes seemed to disappear overnight in a way. I can see how, for example, more and more testing could be done by development teams or application platforms, as we call them here. It's already happening here to a degree, especially our API-based teams. I think as a minimum, really, I think a more generalized or rounded skills are probably going to be required in the future. So that's really where I'm coming from. Now, I'll just start here with how it all actually started. When I came into the team, there wasn't really any source control, and that's not an actual example, but it's a pretty typical example of how script control was done, sort of dates and versions. And as you can imagine, we got into a tangle 2 or 3 times. An application might have several project directories, for example. You might use a version 2 instead of a version 3, and you do an 8-hour run, and it'd be wiped out. You need to do a data generation, you'd be wiped out for a couple of days. So it was kind of a bit of a jaw-dropping experience for me, coming from that highly controlled mainframe system and systems and agile. But anyway, that's where we started. We introduced source control. Actually, originally I think it was Makura, but we swapped to Git a year or 2 later. Okay, so what that meant was once we really had all the scripts in source control, we thought, well, we could plug this into Jenkins and start running the scripts. This is all load runner. The load runner was our really our only performance tool we were using at this point in time. And then someone said, well, we're running these scripts. We can see when they're valid or invalid. Why don't we have a crack at actually executing the load runner scenarios and report generation, load runner analysis as well through Jenkins. So that's pretty well what we did. There are a few limitations which I just wanted to mention about running scenarios like through Jenkins. The first and obvious one is a bad script could wreck the whole run. So we kind of minimize that by using this idea of always doing some sort of validation, then the execution, and then report generation and analysis as three separate steps. We could pretty well run at will, except of course you have to be careful that the applications that have dependencies across each other don't run together. For us, it's database, so you've got to be careful not to do that. And a topic I won't go into today because it's a huge topic in its own right is taking out dependencies on end-to-end systems. We went for a process of stubbing a lot of our critical applications, so we just tested that application and not the back-end systems. That took some time, but I'd say we pretty well got there, and it's really has a major impact on our ability to run tests. Just to give you an idea of what our Jenkins actually looks like, this is like the report job. So when it runs, basically we run load runner analysis, and there's this plugin, the HTML reports plugin you can use, so you can actually put the load runner analysis summary report in with the job, so you can keep track of all your reports online. Now this has got advantages. Obviously, you've got open access right across the company to look at your reports. They're not hidden away on some folder somewhere like they were. It means you can just use the Jenkins link to put into your test summary reports. And the other thing we found, and I don't know why, but especially the first year or two we did this, we were able to detect a couple of major environmental issues going through performance and volume on the way to production, because we had all these systems running together. So we come in overnight, we'd see all the systems like zooming up in terms of their performance. So we'd realised something had gone wrong, and we were able to report it a few times. So we probably saved the company a fair bit of money there. Now, there was one of the downsides of us running these tests all the time, rather than just on the sort of the ad hoc basis before and after sort of a project change, was data generation. The way we were working, we needed to run a lot of data generation jobs before we ran the actual tests. So we were getting ourselves into a bit of a bother there. So one of the first things we did were in terms of the development of Mark 5.9 was to create a simple little application called Data Hunter. It's just sort of a key value CRUD app, but it had the advantage that it meant we could store data from run to run, unless it aged and so forth, but generally that doesn't happen with our system, so it was pretty good. So it was good like that. I wrote it in a way that it uses HTTP GET, so if you're using Webb protocol in Load Runner, it works fine. Later on, when we actually developed Mark 5.9, because it's quite a simple app, it was like the perfect application to use as a sample application. So when you go to our GitHub site that Henrik showed earlier, you'll see this as the sample application. So when I say sample application, we wrote a sort of when we wrote the Selenium, we wrote it in a fashion that needed a very simple DSL. So that became the sample DSL that we've used on Mark 5.9. When I use this word domain DSL, it stands for Domain Specific Languages, and it's really just a way of talking about methods that are specifically written to make an API call easily readable and easy to write. In this case, it's for a Selenium API. I think it was originally some sort of ThoughtWorks concept actually by Martin Fowler. Okay, I'll just quickly show you the screens. That's just the front screen, which isn't really used that much. When you use the sample app, it does have a little, down the bottom there, it's got the H2 database console, which means you can get into the database directly when you're actually just playing around. It's an in-memory thing. When we run sample, it can also use MySQL. All the screens are, I'm only showing you this because it gives an idea of how how the DSL works when I later show you the actual Selenium. So the screens all work the same way. There's an initial add, well, in this case, it's an add policy screen with a simple HTML layout. The responses are all the same. Again, it's very simple layout, and does a few things like show you SQL statements that were executed and stuff like that, just so you can get an idea of what's going on. No big deal with all this stuff. Okay. Now, when we do, one of the major tasks we did here, or the way we worked, it tended to be doing baseline comparisons. We do say a before a change or after a change, or from the last change maybe a month or two ago to a change put in. And what we often found, it was because of the time gap from a baseline to a baseline, we always found a variation. We actually used as a comparison tool Excel, and that was we had a lot here, it lacked visibility. We couldn't really share it easily with our client systems. And it was pretty, it was just cumbersome, and it was easy to make an error too. You miss a transaction or something like that. I did that once or twice, and it meant a lot of manual work if you wanted to actually put the results into like a test summary report at the time that we were using. And what I found in practice was we'd do all this work. We'd go to a meeting. We'd be talking about a run that happened 2 months ago or a month ago. We talk about the run we just did. And there'd be always some sort of variation. It would turn into a bit of an argument maybe, or a bit of uncertainty about what actually caused the variation. Was it actually the change, or was it an infrastructure change, or was it some other change that happened in the intervening months? It was just so hard to tell. So we got the idea of doing some sort of visual graphic, because we don't forget at this point, we've got run-to-run data running daily for our critical systems. So this is what we developed. Now I'll just see if I can actually, without wrecking everything, go and actually show you this live. Where is it? There we go. Okay. So this is the graph that we use day to day to basically, at the end of the run, results run, we basically feed the results into our MySQL database, and then this application, this trend analysis application, captures the data and displays it graphically. So the runs are like down there on the right-hand side. You can see when we've captured baseline, so forth, transactional information in this case down the front here, and unit of measure is always on the Z-axis. The URL is just, again, it's a get thing, so it's easy to cut and paste and share this with everybody. It's open it's open for all the company to see, so it's very, anyone can see what's going on at any time, basically. The more simple sort of filtering is just done up the top here. Like here's the 90 of transactional percentiles. You can do things like just go to the pass, how many transactions passed per run, so forth. Come back here. Just does things like you might want a longer perspective in runs, whatever it happens to be, so forth and so on, stuff like that. You have bits and pieces. For more esoteric sort of work, which we kind of hid down here because it's the stuff that we found in practice we don't use very much. You can pretty well if you've got the time, you can pretty well do everything you want. Of all this, what I've called the advanced filters, probably the most important one is manually selecting runs, because you could compare any two runs together at the same time if you select your runs in the right order. Tabular data means that this beats the old Excel spreadsheets we're using. You can simply cut and paste this into TSRs, or really, at this point, you just really give people the URL and they can do it themselves. And you can do a few more runs to get a little bit more history. Baselines are clearly marked. So that was really the start of Mark 5.9 as a web application. Where did we get to? Okay, so really at this point we've got baseline, we've got baseline comparisons, we've got the load runner report available. We're running in Jenkins. So I'll just go back to my slides. Okay. Did I do that right? Okay, so the next thing to develop obviously was SLA, so that when we run the results, we could actually see whether the test had failed, like pretty visually, basically. So what happens is when the job the result job runs, sorry, we are able to parse the results against an SLI table built into Mark 5.9, and then depending on whether we find errors or not, we color code. The color codes are basically yellow when we've got some sort of SLA, but we would say, like for example, a transactional SLA time has failed. But if it's something a little bit more serious, like we just didn't reach the number of passes or something like that, we basically color it red. And again, on the trend analysis, graphing, we just show it as like red or exclamation mark, so it becomes obvious when you're looking at the graph what's actually going on too. Okay, I'll just quickly, in Mark 5.9, we actually have a series of like data entry screens. They're all pretty similar. I just put this one into the slide pack because to show that we've got these things called the SLA bulk edit functions. What you do is you can basically once you set a baseline, you can basically use that as a method to copy your data across, so you automatically get all the transactions in a sort of a SLA baseline, and then you simply play around with the data to, like, it might be different transaction times for the different transactions and so forth. So it just makes it very easy to enter SLAs en masse, especially if you've got hundreds of SLAs, you know, can be quite tricky. The only other screen I was going to show was this application dashboard, which just gives you all the SLAs at a glance. This particular one is the one that you pretty well see when you actually load the application, when you actually install the application from our GitHub site. Our real one's got about 40 or so applications currently active, so this all looks pretty lonely to me. So we don't actually tend to use this day to day. We actually use Jenkins because we have tabs and we can see the results by application grouping fairly easily. But if you don't have Jenkins, you can just set up like that. This is just as easy too. Okay, so that was all well and good. We're at the point where we're pretty well running continuous integration. We've got SLAs going, but we still found ourselves with one or two issues, especially around scripting. The load runner scripts, especially the web protocol scripts we were running, quite time consuming to change, and because a small change was coming through all the time, we found ourselves spending quite a bit of time just doing script maintenance. So we came up with the idea of of using geometer. We'd actually thought about this for a while, about the idea of using geometer and selenium together, but we needed some sort of trigger, which was an application that was going to be massively difficult to script in LoadRunner, but it had a full Java Selenium suite available. So that became a cost justification for actually proceeding with the Java Selenium solution that I'll talk about in a minute. We didn't really do it because of the cost. We did it for process improvement, but that was just really the trigger. So suffice to say, without going into the details of the actual development, we built the Selenium implementation in Mark 5.9, and then we transitioned really from LoadRunner jobs to geometer jobs, maybe over a 2-year period, I suppose it was. Now the way we did it was every time we decided to every time we decided to move a job from LoadRunner and transition it across to geometer, we actually ran them in parallel. So we could do comparisons. We could check that the actual geometer results, geometer Selenium results, were in line with pretty well what we were seeing in LoadRunner. We did this for multiple types of applications as well. So we had Java, we had .NET, we had just straightforward, simple web apps. We had ones with a lot of JavaScript. We had Google widgets. I don't even know what some of them were. So the upshot of all that is that we are very confident that the solution actually works in a wide range of situations. It's not a toy. It really does work. In fact, we got rid of LoadRunner license progress at the moment, and we're also in the process of handing over some of the P&V testing to the application platforms to run themselves, but using our infrastructure would be how we'll do it. Okay. The Mark 5.9 Selenium solution, it's sort of Eclipse based. It uses Maven, as Henrik mentioned before, and there's our little spot on central, com.mark59. Mark59.com is registered to me, but it's, I think you've seen a slide or two. There's not a whole lot going on there. So that particular dependency is what you need to put into your POM when you're actually writing a script that's utilizing Mark 5.9. When we changed, just a quick one, when we changed across to Mark 5.9, the main change that the users saw were the reports, because we're now using JMeter instead of LoadRunner. What we found with the JMeter reports, they're okay for what we wanted really, but because you've got metric data like CPUs, memory, and data points and transactions all on one big graph by default, it was quite hard and confusing, we felt. So the main change we made was just to split them up, if you wish, into the different types of metrics. Now I should say, when I started all this and when I was invited, I really didn't know. I've got to say, I really didn't know a lot about Neoload. I hadn't really heard much about it. So I went onto the internet and did a bit of a search on Neoload. I think I might have put Selenium into the browser as well. And what came up was Henrik, and Henrik doing this Neoload and Selenium integration video as a kind of a recipe. It's a lovely video to watch. So I thought what I'd do is I'd copy the idea and create my own little recipe. So here's my little recipe. It's just a few things I just want to mention here. I've written fully cooked Selenium DSL. Now, our DSLs have come in two forms. Either we write them ourselves, or we get them from we use the existing functional test teams Selenium scripts. So far, conversion of an existing script has been relatively straightforward. So far we've always found they'll do things like use static web drivers, but it's no big deal to change it to the form that Mark 5.9 needs, which is a Selenium driver per to do. The raw Apache JMeter, that was an important design feature for us. I really tried to make it so that you could download and use JMeter in its raw form without having to hack around or put in plugins or anything like that. So we take a raw one and we basically add to it. We've tried to make it flexible for which particular version of the browser. I'll put Chrome here. We do have a Firefox ability, but by far Chrome has been the most reliable. So we do allow for you to basically put your own driver in. It's got to be compatible with the Chrome version on the machine that you're running on. 2 jars of Mark 5.9 because there's actually a core jar and a sort of a Selenium flavored jar. So that's what that's about. Then when we do the build, basically you get a sort of the script is basically turned into a jar, and then that's put into the libx of JMeter, and that's how you actually execute and switch on the JMeter and run. I put this slide in. I'm not going to go through it today, but if you're actually trying to get an idea of how Mark 5.9 hangs together, this is until we get our documentation completed. This is probably a good sort of ready reference, just to see how data flows between when you're doing the development work in Eclipse, when you're running in JMeter, how the test results file gets moved into report generation and loaded into the database used for that trend analysis graphing. Okay, let me just go into a few basics about scripting. We use a JMeter function called the Java request, and we've basically extended the Java request for our own purposes. The Java request in JMeter is just a way to run a Java program, and really Selenium is just a Java program. So that's the basic concept. It's what we've done. Now, this is the screen I've got up here is the parameterization that we used when we're creating a Mark 5.9 script. It basically has 4 main divisions. That top section is the script specific parameters that you may want to use, per script. The second set down here are the parameters that are used to actually create the driver. So the options are Chrome and Firefox. Do you run headless or headed? Page load strategy is an interesting one. I might briefly talk about that later. You can set a proxy. Additional options are, there's hundreds of additional options. You can put incognito in and all sorts of things. That's your basic driver settings. The next thing you've got are log settings. I'll talk about that in another page or two. And one down here, which I've called miscellaneous, is just a way to handle distributed testing or to help with distributed testing in JMeter. If you don't know, the way JMeter does distributed testing is a bit different to other tools. It just makes a copy of itself over and over across all your injectors, and it just runs everything the same. So you don't necessarily always want that. So we've put this in so that you can restrict your particular script to run on a given or a set of given injectors. It's an easy way to control distributed testing. That's what it looks like in the actual Java. There's pretty well a one-to-one correspondence between these parameter values and what gets passed across into JMeter on that screen I've just shown. Okay, so this is the general structure of our scripting. I've already gone through additional test parameters. The guts of it is the run Selenium test. This is where the actual script goes. The browser gets passed into this method so that it's available as you're clicking through the Selenium steps, and you tag your transactions with these start and end tags pretty well like in most tools. What was really important and became a major, well, it seemed to be very important to the testers, and I can understand why, is that I added the ability to run directly in Eclipse so that you could run before you actually did the build and checked it in JMeter. There's various levels of complexity. You can just run a nice simple one. You can run with 2 or 3 browsers going at one time, and then there's one where you can even pass a run with a variety of parameters, like if you're using different users or whatever it happens to be. And by the way, that's why I got to Meter 4. That's got asked pretty late in the piece. So, but I could see the importance, and it got added. I'll just go through the basics of the Selenium DSL that I built for Data Hunter. It's a very simple one, but it just gives you an idea of a nice, simple way, I think, to code a Selenium test. So you've got good control, and it's easy to understand and easy to write. Actually, this particular DSL I put in Data Hunter, it's a sort of a three-pronged thing, you could say. Really, it has page elements, and each page describes the type of elements that are what elements are actually on the page, and then the next part of the is basically what you can do with that element. So here I've picked the add policy page that I showed earlier in the piece, and I'm just going through this usability drop down here. I'll put on the left hand side, you can see. So that line basically is the line that selects unused, for example. So about all I'm saying is this is the add policy. This is the add policy page that was in that bit of script. It just lists all the different types of elements that exist on that page, and gives a link to how. Well, the link basically says how to access that element. And this particular one, it's a type of drop down, and then the next part, and then the last part of this sort of DSL is a description of what you can do when you're on that kind of element. It's a drop down, so the most common one is this select by visible text, and that's what you saw being done in the script. So that's really the basics of Selenium scripting. But what we found over time, and what we're going to have to do I've decided before we actually call it a formal release, is include a DSL that uses these wait conditions. As the applications get more and more complex, what you find happening is you simply can't rely on a click to come back. What you find yourself doing more and more is you say execute a task, a click, or what it happens to be, and then you need to wait for something to actually happen. It happens, then you do the next click and the next click, click and wait, click and wait, click and wait. We originally developed a simple little Java class called the super page element. We've put into the Selenium implementation, thinking of it as almost an aside really, but it's become obvious that this is actually core to writing a really solid Selenium implementation. So we're going to, the last big thing we'll do is pull all this out, put in a sort of a sample DSL, and hopefully that's going to make scripting a lot more easier going forward. The last kind of thing I just wanted to mention about scripting were our logging events. I think problem determination is just absolutely so important in performance and volume. You've got data flowing all over the place. You need as much help as you can get, I think. So with our logging, we've got different levels that you can log, but the main components are at different levels and at different times. But the main components that we basically have are basically just a simple screenshot. Screenshot goes into the log. You've also got the option of writing the actual HTML that's on the page into the log. And if you're using Chrome, Chrome has a log called the performance log, and that basically gets down into network level. So if you're really keen to look at the HTTP request, HTTP responses that are going on, and 2,000 tons worth of network stuff I don't really understand, you go to this, you can print this log out. So in fact, that's the way you get into the HTTP request response level in Mark 5.9. Another important aspect that I want to finish off before we actually call it an official release is our documentation. I'm treating Java docs quite seriously here, because at the end of the day, you're writing the scripts, and I think it's great if you can actually see the documentation in front of you as you're going. It's only about halfway there at the moment. So this is one of the big things I really want to accomplish before we finish. It just makes it so much easier, I feel, if you've got some great Java doc in front of you that's kind of like user orientated too. So you actually know what to do when you're looking at method name. What does it actually do? What are your actual values? But I'm not quite there yet with that. Mark59.com, which, as I mentioned earlier, I had to register in order to get into the Maven Central. Is a little bit of a blank at the moment, but hopefully we'll get something up there fairly soon. That'll contain our formal documentation, the actual executables and so forth and so on, stuff like that. I'll just very quickly, if I've got time. Okay, just got time. I'll go into Jenkins. I've pretty well alluded to how we run Jenkins. This is like our sample data hunter tab. So all our jobs we've constructed a build and deploy, so we don't have to do anything manual. It's all sort of bat file driven. Then for the data hunter, I've got two job sequences here. One where I just run a single injector, and that bottom four where I run a distributed test. You'll note the distributed test has got one more job in it, the JMeter services, and that's because when you run JMeter distributed, you've got to tell all your servers that they've basically got to start a process. So you've just got to hit the injectors and start the services in those injectors before you can actually execute. Other than that, it's actually pretty similar. Just to give you a demo of how we've actually constructed the Jenkins jobs, we always use the same bat files just to keep things consistent, and then we parameterize them as much as we can. This is the check. The execution looks almost the same. What we do with JMeter jobs is we just run one user against the actual test plan. And if that works okay, then we fire off the actual execute with, well, however many users that it actually needs. Distributed results are pretty well already shown. Probably the only other thing of interest is we actually put in this little IIS web service so that we can go directly into the injectors and actually see our screenshot directories, our logging. Just makes it a little bit easier. And again, just an example of how we've parameterized our Jenkins jobs. It might seem like a little thing, but when we did this, it just gave us consistency and made life so much easier for us. And the last thing I've really got to talk about here is our actual execution capacities. So I did this last week. I went into our jobs, our Selenium jobs, and just did a bit of a look at what sort of loads that we're actually running. Oh, I guess the most interesting one here is down the bottom, our largest one. It's our largest app that we actually test. It's running Selenium, so it's doing 44,000 transactions an hour across 2 servers. When I say recorded transactions, what I'm talking about are those begin and end transactions in the script. So I'm not saying that's a one-to-one with a HTTP request or response. That's going to vary depending on how much AJAX or how much JavaScript is actually in the application. But it does seem to be pretty, there seems to be a correspondence with recorded transactions and capacity from our experience, basically. And just to go a little bit further with that particular test, the 44,000 transactions now running 100 threads across the 2 injectors. Here's our little graph. You can see we do get, even with something as well controlled as our injectors, we do get this variance. Mind you, notice the z-axis here is not from 0 to 100 or anything like that, so it's not quite as bad as it looks. But we do get the 15% or so quite often from test to test, but it bounces around about this 30-40%. I probably should have said back on the previous slide that the cutover point when you're running on these VMs that we're currently running on is about 50%. Once you start running over 50%, we definitely see degradation in response time. So that's about the limit. I might just go back once. Go back one here. Should mention too, we're running like fairly large injectors, but not supersized or anything like that. So down here at the bottom here, I've put what my guesstimate is for our capacity before we go AWS. It will be probably about 10 servers. We run verification on 7 servers per day. That runs fine. I think it'd be quite practical to go up to maybe 10 before it starts getting a little bit dodgier, and you might need some sort of extra subtlety in handling all those injectors. So at 44,000 divided by 2, let's say about 20,000, then by 10, I would say 200,000 transactions an hour is what I would consider a reasonable practical comparison. I'll get it out. Practical sort of capacity before you might want to start thinking, is Selenium really the right way to go here? And you'd want to think of another technique. But it's certainly not trivial anyway, that sort of load, I feel. If the project actually gets traction, we'll put stuff into Stack Over. We'll basically monitor Stack Overflow, ask questions there. Henrik's already shown the IGCL Mark 5.9 site, and as I mentioned earlier, hopefully we'll get something up on mark59.com. And just quickly, there's a whole pile of things I've got here listed that I haven't covered, like metrics capture, which we do in a fairly simple way. Pacing was actually a big one for us. That took us a bit to get right. I was going to talk about AWS, but we were almost there actually, but not quite, so I didn't want to cover it. We have tested and run on Linux and Unix, but at the moment we're running our infrastructure on Windows and a few other odds and ends that I haven't got to. So that's really it. I hope that's made some sort of sense to everybody. And I'm open to questions, Henrik.
All right, thank you so much, Philip. I have, in fact, a couple of questions. In fact, I see several PAC members connected, so I've enabled their webcam, but SK is, I think SK is not available, but Harry is there as well. So, well, first of all, thanks, Philip, for sharing this open source. So I have a lot of questions.
No
so I was going to ask them. And there is no Q&A, no questions from the attendees. So I'm going to go through my questions first, and then I'm going to ask Stephen, Harry, Jabali if they have any other questions as well. So first of all, I don't know. It's just I was wondering. So why did you name it Mark P59? Is there
You know what? I thought that might be the first question. Okay, so you know, funnily enough, we never got asked when we open source these things. I don't know why, but it never did. So what I was looking for was some sort of saying to do with a situation where you've got many of something when you're expecting one of something. And of course, I'm into, I like my heavy metal, so I like to think I'm into devils and all that sort of stuff a little bit. So I thought, is there a situation where only one devil was expected, but in fact a whole pile of devils turned up? Devils, like representing selenium, basically, going from one selenium to lots of selenium. And it turns out, as in the New Testament, in Mark chapter 5 verse 9, there's a saying, and I'm running out of brain power. I'm trying to think of what it says. It says there's something. Oh, Jesus turns to a man who's basically possessed, and he demands the name of the devil that's in the man, the possessed, and the devil says, our name is Legion, for we are many. So I thought that was a nice sort of little twist there. So that's where it came from. So sorry about the long-winded answer, but we had a lot of fun creating that, actually.
So you're telling us that the selenium is the real devil?
It is indeed a devil, yes.
Other question not related to the name. As I saw that you have different status. You have yellow for warning, red for failing, and it said that if one SLA fails, it's going to be tracked. And I was wondering, when you start automating performance testing, you try to get a pass-fail out of your test, because to be able, if you build an efficient pipeline that Stephen explained us this morning, if you're not able to give a status to the test, then you're potentially either blocking the pipeline, either passing the pipeline. But you want to block or pass the pipeline with the real decisions, so automated your decision. So I was wondering if the pass stuff. How do you? So you mentioned transaction. You mentioned response time, but I was wondering if you were including also infrastructure, because it really depends of who the performance engineers as it is, because a lot of people is only considering response times, but I think performance is a combination of response times plus other metrics. Defining an SLA, you need to consider the rest of the metrics. So how do you manage this?
Yeah, so by the way, all this happened quite quickly, I should say. From writing doing the pipeline, we realized almost straight away we needed the SLAs, because otherwise we were going in and checking every morning to see what happened in the test. So that bit actually came quite quickly, SLA verification, color coding. What I didn't mention too were that we sent out emails to the platforms, and some of those platforms, especially critical applications, they're looking at those emails very closely every day and looking at our as you say, our color coding, and will come up to us very quickly if they see a yellow or red. There's actually two forms of metrics. I showed the transactional SLA metrics mainly because of that bulk copy function, and because in the past, the tools I've used, you've had to enter SLAs transaction by transaction, and it's just so slow and so error prone. So that's why I just showed transactional. What I didn't show was metric SLA. So the way the tooling works is basically you can pretty well choose whatever metric you want. Right now, though, we capture CPU utilizations and 2 or 3 different types of memory stats. But although I didn't show it, there's a series of graphs around metrics, and they have their own SLAs. And in fact, what it is if a metric SLA fails, which is like CPU utilization or well, it hasn't really happened with us with memory, but certainly CPU, we always go yellow because it means that the test has run successfully. We got to our required pass counts, and and it will only fail if we don't reach the pass counts or percentage error rate of transactions is too high. So metric SLAs means we've got a valid test but a failed SLA. So they always go yellow. So yeah, both are covered. Yeah.
So so I don't know if so we discussed it during the last pack in Chamonix, the pack members, and also we implemented approach with Andreas Grabner and the captain of the SH framework. So I don't know if you're familiar with the Kayenta project. It's something that has been shared by Netflix and Google, where the terms SLA doesn't make having several SLA for a test doesn't make sense, and you have an SLA for one test, one single SLA, which is if I have this and it's passed, and if I have that, I get failed, and then the idea is more about putting a score. So let's say I have a transaction. If the transaction is under 3 seconds, I will get 50 points. If the CPU is in those thresholds, I get 50 points. So basically, you're defining the metrics, you're defining the score that you can get from each metrics, and then at the end, you place an SLA saying my test will pass if I have a score of 90. If above 90, it's a green light, and under between 90 and let's say 70, it's a warning, and under less than 70, it's going to be a red test. So I'm going to block the pipeline. But I don't know if you can you have fun with it, but I think it could make sense to have that.
Yeah, I like that idea actually. I've heard of similar concepts. We haven't actually had a request or anything, or that hasn't really been discussed actually, but I can see where you're coming from. Right now we're a little bit more fine-grained, right? We just look at the metric we're talking about, and if that metric, like a CPU utilization, goes over whatever the percentage is, it just automatically goes yellow, and that's as far as we've really got. The only other discussion we've had on metrics was this concept of having formal SLAs and informal SLAs, because when you're dealing with teams, you often get the formal SLA is 30 seconds. One of our applications is actually 30 seconds, but when you're running a performance test, you never see anything above 6 seconds. So I've actually set the SLA a little bit above 6 seconds, like a 10 seconds. So, but if it gets to 10, I know there's a problem, even though it's way below the formal SLA. So that's really the only discussion we've had along SLAs, but it's a very interesting idea, Henrik. I'll talk to the team about that one. Wouldn't be that hard to do, actually. It's just a bit of mathematics.
Okay. Other question is more related about, you mentioned about the concurrent threads that you had and the Doge meters, and I was wondering, because it's from my understanding, may tell me if I'm wrong, you're generating a pure Java-based Selenium scripts, and so it seems that you're not utilizing a grid or a Selenium server to delegate the execution. So I was wondering, directly web driver. Yeah. So I was the first reaction I had is so I'm deploying my JMeter, and it needs to have the Chrome driver or whatever driver I have. I need to make sure that I'm also deploying that driver there. So the deployment mechanism, I guess, I don't know if you have prepared some containers that has all the potential driver included in that. So I was a lot of questions because it's not going to be a standard JMeter load meters. You need to add those drivers on top of that.
That's right. That's right. When I went through the recipe, that was what I was saying. We actually have to add the Chrome driver into JMeter. By default, we generally put it into the bin directory, so it's a pretty obvious place to put it. But the other thing I did go through when I was just showing the Data Hunter Jenkins was the build. Now, what happens is we've actually got all our injectors currently aligned on Chrome 73. So in the build, we have Chrome compatible Chrome driver 73 in that build. So it gets it from there during deploy and puts it into the instance of JMeter that's going to run the test. Now, this particular laptop, for example, runs Chrome 76 at the moment. I try to keep it a little bit ahead so I can see if there's going to be problems coming up. So that's in that little data flow diagram I was showing earlier too. I'm running locally on Chrome 76, but the deployment job has got that Chrome driver 73 in it. So when I actually deploy across, picks up Chrome 73 and will execute on that injector. So that's all taken care of in our builds, basically.
Got it. And my last question before involving the other pack is you mentioned you're using the Chrome console, so you can expose and put that on the logs.
Chrome, yes, that's right. It's called the log, performance log, yes.
Yeah. So I was wondering if you could instead, so that's more like a backlog request, feature request. Instead of that, if you could generate a standard report, which is HAR files. HAR files, I think it's a lot of HAR readers, and so it's a standard now. So instead of using something that is only sort of Chrome format or for Chrome related, so having something that is standard, and then you can basically expose it through the Mark 59 UI, expose the HAR file, so you can basically see the drill down.
Yeah, I know where you're coming from, because the thing is, if we're running Chrome driver, that performance log is what is available in Chrome driver. Really, the problem is really that all we've been able to do at this point, and we actually had a crack at trying to get the performance log into some sort of graphical report, but we couldn't get there. We actually had a crack at it, so I know exactly where you're coming from. We couldn't get there, so at the moment all we're doing is just dumping out as a textual file. But we know that performance log, that's actually is or very close to what you see when you run the developer tools on Chrome. It's on the network what do you call it, tab. So it is very close to that. We couldn't quite work out every single network call, so we couldn't actually convert it into something graphical. We did try that actually, but again, I guess it comes back to we are just a small little working team, and we just didn't quite have the skills. We got close, but not quite there. We actually have, I've actually saved all that work off, and sometime we may go back to that actually and see if we can actually get something graphical out. I saw in Neoload does all that stuff. It's pretty cool actually, but we're just a little open source team, so we couldn't get there.
Okay, so I got it. I think it's interesting. I think there is promising because I see a lot of things that could be helpful. It's pretty funny because there is a lot of things that you're using in your approach that we are doing, but not with JMeter or with an open source, maybe any other.
Yeah,
that's pretty cool. So I'm taking now. So I have no other question from my end. I'm Harry's webcam that is connected, but not currently available, so I will disable his webcam. But otherwise, Shrivali, Stephen, do you have any questions related to Mark 59 and to Philip's presentation?
Do you want to go first, Shrivali?
Yeah, sure. So I might have missed it, but so do you reuse any of the functional test automation scripts, or is it like a completely different way of scripting?
Yeah, so there's two approaches that we use. One is to grab an existing functional test suite. So we've done that a couple of times and then sort of fit it into the Mark 5.9 framework. I did briefly mention in one of the slides actually. And so far when we've done that, it's not been that difficult to do. In fact, that's kind of it really is kind of the driver actually is to why we developed the way we did, so we could take the Selenium. The Selenium is like almost separate to the JMeter component, and we're an integration point. So that was really quite important to have that capacity to use an existing functional test. And what I just mentioned too, when I was talking there, the only thing we've found with all the existing automation regression suites that I've hit so far is that they tend to use static web drivers. So what you need to do is basically make sure that it's Mark 5.9 creating the driver and the drivers per thread. But in practice, that's actually been quite straightforward code change, actually.
Okay.
And yeah, and the other thing is like we've done a lot of DIY, do it ourselves scripting as well, which is why I've talked a little bit there about the DSL. Because that took us it's quite a learning curve, to be honest, to get from a simple DSL to those weight conditions. Took us a little bit of time to get there. Like I said, we worked through this over about a 1 or 2 year period, and now we're fairly confident we know what we're doing. And that's why the last thing I'm going to do is build that sample DSL. So it should help everybody else out too.
Yeah. And
no, thanks.
thank you for that. And
that's okay.
another question, not quite question, but I totally get it, like what you mean by, easy to maintain, because quite recently I had experience with one of the projects where the network traffic for one of the interfaces I was testing was so complex that there is no way I could have get that done within the time and budget. So I have used JMeter WebDriver for only that web application, and everything else I have used traditional JMeter way. But I do worry about the scalability, for the load that I'm applying for now. It is fine. I'm using 2 machines and it's fine. But if in the future, if the load increases, the maintenance of this infrastructure and, other issues that come with scaling of these GUI users. So yeah, that's what I'm a bit worried. So.
Yeah, that's the question I've had every single time I've talked to anyone about this, is the scalability. Actually, I hadn't even gone onto the internet to see what people have written about this. And if I had have done 3 or 4 years ago, we probably wouldn't have even started. But what those figures I gave a little bit towards the end of that talk of about, I would say, I think I said it's about 200,000 transactions now. Now that's not a trivial system to run at 200,000 transactions an hour. And like I showed, our largest application that we're currently testing, in fact, it's our largest application outside a very high API sort of transactional system, is that system at 44,000 transactions now. So we're running 44,000 transactions an hour across 2 servers very easily. I think we can scale it up easily. That would scale easily to a multiplier of 5 is my guess. So I think we're talking quite large systems before you're hitting limits.
Yeah. My understanding is that it supports higher throughput transactions, but in terms of concurrency, I think that's where it hits the bottleneck first. No?
We haven't found that. The only thing I would say about the problems there with concurrency and trying to even out the transactional flow through the test was we did have a lot of problems with pacing, actually, which you wouldn't think you would, but it's because the way JMeter is written, it's really written as fundamentally to do HTTP request response, API work. So all the timers I think how it works is all the timers assume you've got a pretty short time, not like 2 minutes or I didn't even talk about it, but there's an iterator class as well that I've written, and that could run for 20 minutes. So those constant throughput timers, all these timers that JMeter have, don't seem to work very well. So we did actually have to develop our own sort of little timer. If you know Load Runner, it's basically sort of a Load Runner type 3. It just does it just will trigger every, say, 20 seconds or 30 seconds, unless you run over the 20 seconds, and it will just kick off immediately, sort of thing. Concurrency, no. We do have to ramp up. Obviously, the Chrome driver has a big hit as it actually instantiates. So, but as long as you basically ramp up a minute or two, we really haven't had a problem. No, concurrency hasn't been a major issue up to now, anyway.
Okay, that's good to know. Actually.
Yeah.
Yeah. So I just looked at the specification of the load raters, and I saw 24 gigs of RAM, and I said I never had the chance to have that type of machine in my hands, so you're quite lucky. Yeah. But no,
yeah, I mean,
I think it's
they're big, but
it's pretty insane machine to generate load, but.
Yeah, well, you know, it's what we got. I mean, they are big, but they're not, I wouldn't say they're insanely big for corporate level. You know, the costs aren't insanely high. What I'm really interested in seeing is what's going to happen when we go into AWS. That'll also reduce our cost dramatically as well, is what I'm told. So we might be able to get some really big machines, and I think we'll be able to run a lot more. Distributed testing should scale horizontally big time. So I think I think we'd be capable, if we wanted to, of running quite high loads in AWS. So I'm quite looking forward to seeing that. We just, the only thing is we actually need a system to test that's large enough. We don't actually have one at the moment, but I think there's a few big ones on the way, isn't there? So we'll see.
I think Amazon is a great example, and you heard about the cost of the cloud with Stefano this afternoon. So I think 24 gigs of the sizing that you've described, the cost of the machines, it will be a bit high. So I think if you do one single test, it's going to be fine. But if you do a test every morning, I could imagine that few project leader or project manager or financial directors or whatever will probably point out, say, hey, what is that cost? I mean, what are we doing every day? And you're coding that billing every month. It's ridiculous. So yeah.
Yeah, we're not sure. Yeah, we're not. Yeah, I'm not sure about that. All we know is that we took the our sort of our workflow, how we're actually running and executing across time, how many tests we're running. And we were told quite confidently by our AWS team that we'd be looking at about a three quarters sort of cost reduction. So I guess that's to be seen, but we can only hope, really. I'll have to come back next year and tell you.
Okay. Or you can even come to our physical packing and share more insights on that.
No problems.
Any other questions, Stephen?
I'm viscerally aware that we're running out of time. You probably need your fifth coffee. I need my second gin. So I have one question, though.
Okay, I'm pretty well out of voice, so.
Just a real quick question. Chrome in headless mode. Can you take screenshots of a failure occurs while it's in headless mode?
Yeah, that was it. It's in both modes. So during failure, again, I just ran through it so pretty quickly because I probably had too many slides, but we take screenshots on failure. You can take them on a transactional level. You can vary depending on your log4j debug level when you take screenshots. It doesn't matter if you're running headless mode or headed mode. It does matter in terms of how the scripts actually perform sometimes, but actually run, I should say. Strangely, performance and injector load doesn't seem to vary a lot whether you're running headless or headed, in my experience. Not sure really why. I always thought that UI should considerably add to the load, but hasn't been my experience. Yeah. We haven't tried running one. I might try running one of those big runs and turn it into headed just to see what happens.
I think you were saying 200,000. The biggest test that I run is about 130, 140 transactions an hour. So you're
right, yeah.
my biggest test, right?
Yeah, I think you don't have a problem. Yeah. You can run on one little tiny injector, so Henrik won't have a problem with that one, I don't think.
All right, Stephen.
Okay.
No questions?
No, not today. We'll talk
okay. So I think we have just finished the APAC, the Australian New Zealand region. So I'd like to thank you, Philip, Rivali,
thank you,
and Stephen for your awesome presentation, your involvement. So like I said, feel free to connect. If you're after 4 or 5G and you can still connect, Stephen, I guess, and interact with us, that would be fun. So I will make a break. We will reconnect in 30 minutes, where I will do a small introduction to introduce the Central Asian location. While that, I will put a small break video so you could be entertained during the next 20 minutes. And I will be back in 30 minutes. So thanks again for Philip, Rivali. And that will be really awesome. You just started the conference in the right directions. That's great. Bye.
Thank you. Thank you. Bye.
Thank you. Cheers.